Hello. Hi, everyone. So I think we are like 15 minutes past 10, so we're about to start, if everyone is OK. My name is Ted Vilutis. I'm a product manager working on Fabric product. I'm specifically working with data engineering experience, and I'll tell you a little bit more that during the presentation. Here's also my colleague who will be main presenter and talk about OneLake. Josh.
Thanks. Yeah, hi, I'm Josh Kaplan. I'm the product lead for Microsoft OneLake in Fabric. Everyone heard of OneLake at this point? Everyone know what's going on literally right now next door? That's kind of want to go look. But yeah, so if you don't know, we're actually announcing the GA of Fabric right now. So as of a few minutes ago, it is generally available. And I appreciate everyone skipping that announcement and coming here. We'll do our best to give you an overview of what's going on right now and tell you some of the new stuff that's come along the way as part of Fabric and OneLake. And this is the first time Ted and I are doing this session jointly. So I typically go through OneLake. And now Ted's going to come in and also tell a little bit more about the data engineering pieces, which is very much related. And we'll see how the two work together. So let's get started. So OneLake is the center of data gravity across your entire multi-cloud organization. And we often call OneLake the OneDrive for data. I know sometimes there's a little eye roll when I say that, but I'm going to explain to you why we call it that and share more details around why that's so valuable. So when we really started down this journey, I talked to a lot of organizations. And I could clearly see they had these visions of these very pristine data lakes. These data lakes would provide one clean place to land all your data, whether it's structured or unstructured. Because it's in one place, it's really easy to analyze it together, blend it together. It's really easy to secure it and govern it and share it and distribute it to all the users and applications who need it. That's the vision, that's the goal. Reality, a little different. Getting to this reality is very difficult. Analytics with data lakes is a lot like file sharing prior to OneDrive coming along. If you remember back to those days, you wanted to share files, you got servers, and you set up these network file shares, and you created folders, and you essentially used storage to share your files. And it worked, but you built the pattern on top of that to actually go ahead and share files. Then OneDrive comes along and gives you a SaaS service for sharing files, which really changes the game of how we share files. But it's even evolved way beyond that. It's not just sharing files anymore. It's collaboration over files. It's governing files. And we won't look back to the way that we used to do this before these SaaS services came along. And data lakes are very much at that same point right now. You can't buy a data lake. Officially today, you can buy a data lake with the GA of Fabric. But prior to that, you cannot buy a data lake. You bought storage. And you would implement a data lake pattern on top of that. And this really isn't easy. Very quickly, that one unified, pristine data lake vision goes out the window, right? Because there's some technical challenges, but there's a lot of people challenges there, a lot of organizational challenges. You have to work together across teams and agree on standards and agree on how you're going to lay out your data. You know what? It's just easier to build your own thing. And that's where really the data mesh pattern started to evolve. It's like, all right, we're not going to have this coordination challenge anymore. We're going to have every single business domain run their own lakes. And OK, we solved that collaboration challenge, but we've created several others, including the fact that we now have to manage all these different resources. Whichever path you go down, the result's typically the same. Really multiple siloed lakes, and run by different business domains. And these lakes can span different parts of Azure. They can span different clouds. Now, you've got to figure out how to bring this all together and really get that value out of the data. So to really get back to that original vision, what do you start doing? You start moving data around. Try to start consolidating it. Break down those silos a bit. But even after moving the data and consolidating in places, most users, most applications don't know how to work with a data lake, don't know how to work with storage. So you build a serving layer. This consists of data marts, data cubes, data warehouses, Power BI data sets. Unfortunately, these aren't just referencing the data in the lake. These are copies of the data in the lake. And sometimes they're copies of the data in the lake. Before you know it, you have data that's really flying all over the place. And you're building systems to manage this. You're building systems to keep the data in sync. You're building systems to govern the data. And you're dealing with what happens when they're not in sync. and you have to investigate and bring things back online. And it's an ongoing cost, not just an upfront cost. But you do it, because there's a lot of value here that you can get out of this data when the solution is complete. Anyone experienced this before? Again, a lot like file sharing. Going back to the days before you had a service that did this for you. So moving forward now, OneLake aims to provide you a data lake as a service without you needing to build it yourself. You've had OneDrive for your documents, and just think how that's changed over the years, the way you work with files. Now you have OneLake for your data. OneLake provides you a single unified data lake for your entire organization. For every Fabric tenant, you'll always have exactly one OneLake. You'll never have 0. You'll never have 2. We literally have the name, so it has to be 1. There's no infrastructure to set up or manage. And we get some unique benefits that we have in a SaaS service that we didn't have in a PaaS service. We have this concept of a tenant. A tenant tells us where your organization begins, where your organization ends. So it gives us this kind of natural governance and compliance boundary. All data lands in OneLake by default and lands within this boundary. So all data is governed by default and takes part in out-of-the-box data lineage, data protection, data governance, any of the catalog integrations we have, just by landing in OneLake. Now, this initial boundary is set by a tenant admin. And the tenant admin is ultimately responsible for everything that goes into OneLake and making sure it meets the basic requirements. But we don't want this tenant admin to become a gatekeeper. We don't want to get into that situation you saw before where you had different parts of the organization just finding it easier to go create their own lakes and do things differently. So just how easy it is in Office to create a Teams channel or a SharePoint site, we have workspaces in Fabric in OneLake. These workspaces allow distributed ownership across the organization. Different parts of the organization can create their own workspaces. And each workspace can have its own admin, its own capacity for billing, and have its own access control. So while the tenant admin can set the initial boundary, workspace admins can fine or tune that security and governance within their own workspaces. And they can do this completely independently of everybody else contributing to OneLake. But everybody is always building into the same lake. Question?
Can I ask a question?
Sure.
So on subscriptions, are you saying that you have the concept?
So workspaces, so our subscription is relevant here, Azure subscriptions specifically. The subscriptions become more relevant when we start talking about capacities and billing. So every workspace will belong to a capacity, a Fabric capacity. Fabric capacity can be purchased 2 ways right now. One, if you have a Power BI Premium capacity, that works as a capacity. That's purchased through Office. The other way to get one is a Fabric capacity, and that's through Azure. Those will be tied to a subscription, a resource group, but you get a capacity. That's for all of Fabric. That will include OneLake. OneLake spans the capacity. That will include your access for using OneLake, though, when you get that capacity.
So it's a resource boundary, but not a security boundary.
Correct. Yes, you have OneLake for your entire organization in this. So always the metaphor here is think back to Office. You have one SharePoint, you have one OneDrive per tenant. If you have multiple tenants, you're going to have multiple at that point. But per tenant, you have one of everything. So think back to how you do it in Office, how you manage costs, how you manage security. Very similar concepts here.
That's the whole of Fabric or just?
That's the whole of Fabric. So workspaces allow this distributed ownership. But we took this one step further. Workspaces are really tied to a project or a team. Now, you have multiple business domains that will have lots of projects, lots of teams. So they're going to, in essence, have lots of workspaces. So you don't have to manage all these workspaces individually. So we took the concept from Data Mesh of business domains, and we made them an actual part of the product. And domains now provide a governance boundary in between the workspace and the tenant. So you can have workspace admins, domain admins, who can now manage the security settings and policies for multiple workspaces in one shot. They have official workspaces that now can group under their domain. And they can manage the additional security on top of that rather than managing it one by one for every single workspace. So now we have different layers of management and governance here. So hopefully you can see at this point how you can have a lake that is easy for everybody to contribute to. Because by default, everyone is going to be contributing to it. But usually it's this point of the presentation where someone asks me, OK, I don't want certain people to contribute. I want to block certain access to the lake. Because really, I don't want our certified IT-blessed data sitting next to some data that someone just brought in. And my response to that is typically, if you stop them, which you can stop them, if you stop them, though, they're going to put it somewhere else. And you have no idea if that data is governed. You have no idea how that data is being used. At least if they put it in OneLake, which should be the easiest path for them to land their data. Just like OneDrive by default is the easiest path when you save something in Office, OneLake should be the easiest path to land their data. You know it's governed by default. And you can see how it's being used. Now, we have this concept called data endorsements. Data endorsements let you certify data, recommend data. And you can now do this by domain. So the sales domain can say, this is our officially certified data. You should be using this. And that will come across when anyone looks for the data, when they discover it, when they use it. And what should happen here is your certified official source of the data rise to the top of the lake, while everything else starts to sink to the bottom. But if that doesn't happen, let's say what's supposed to sync is actually very popular and very useful. You can see that, and you can start to take some action. This is not something that would happen if you let them build their own silo and land the data outside of OneLake.
Question.
Yep.
So when data is coming in into OneLake, how do you ensure that the data goes into that first layer before it goes into each respective domain?
Well,
How do you make sure that that silo doesn't? What happened in OneLake to ensure that data is not siloed when it's coming in from all over?
we'll show you a few demos of how we actually bring data in and how this works. And sometimes you ultimately do want a silo. There are reasons for that too, but data comes into OneLake. Think again like Office and SharePoint, right? You have the access control. It's not like everyone sees everything by default. You have ACLs and controls you place on your data that control the discoverability and control who can see it and use it from that point forward. Now, if you don't want anyone to access your data, you can do that. But when you want them to access your data, you don't have to get different resources to talk to each other. You don't have to set up network boundaries so these things can now connect. You don't have to pay for these extras to make sure that you're tunneling traffic through. You can set the ACLs, you can set the roles and the permissions, and everyone can access that data at that point. It's also about this point in the presentation, someone tells me, we can't have just OneLake. We have certain data residency requirements. Our business is all around the world, and we have certain users whose data has to stay in certain regions. We have you covered on this one, too. OneLake's built on top of ADLS Gen 2, but it is not a storage account. Under the covers, we use thousands of storage accounts to make this work. And we store data in multiple different locations. So based on where you tell us your workspace should be located, we will choose physical hardware in a physical location to put your data in that region. And the data will always reside within that region. Now, we virtualize this away into one logical lake. So you're not managing these additional resources. To you, it's just OneLake. Under the covers, we're handling the different storage accounts. We're handling making this look like OneLake to you. So you can achieve data residency this way. Additionally, by default, we're going to store your data with geo-redundancy. So we'll store it, zone redundancy by default. So any particular part of a data center goes down, you have some redundancy there, keeps your data alive, keeps your data safe. With the GAF fabric, we've also introduced the option to turn on geo-redundancy, which will also automatically replicate your data to another region in the event of an actual catastrophe where you completely lose an entire data center. So both of these now are available as part of the GAF fabric. So far, we've only been talking about really the storage. It's compute that.
Before you move off
Sure.
storage, so what you're saying that it's all stored in the Azure storage, which obviously has the ability to store a variety of different things. Can you enumerate the type of things that the OneLake is designed to
Yep. Yeah, so the question is, what is OneLake designed to store? We talk a lot about tables, and we talk a lot about tabular data. And actually, the part I'll show you now is what we'll do for tabular data. But we're a data lake. And it wouldn't be right to call us a data lake if we didn't store every type of file. Binary files, structured files, unstructured files, images, photo, whatever you want to put in there, OneLake will store it. We'll support anything ADLS and blob support today. How do you handle multiple environments, dev, test, prod? And this is not specific to OneLake in this case, but you have one SaaS environment. So you don't have to worry about managing physical environments anymore. But what you would do is you would manage separate workspaces, separate domains some customers have even done. But you have a dev workspace, a test workspace, a production workspace. And then we have pipelines built in that will actually help you automatically move stuff across if you need to. And then you can also do just standard CI/CD practices of moving the data across. But the workspace would be your boundary there. You can do that. So if you want to have different SKUs for the different environments, the main reason to do that is you want to bill them differently, and you want to have different scale for each environment. And you don't want like your dev environment to use up resources for your prod environment. Essentially, your data is going to be, your environment is going to be in a workspace or a set of workspaces. Workspace is going to tie to a capacity. The capacity is going to tie to your Azure Resource Group or subscription. You still only have one OneLake. Yep. Always one. I take one more question, and some of the stuff will be answered in a little bit too. Let me go through because we're going to touch heavily on that. So far we really have only been talking about the storage itself. It's the compute that powers all the analytical experiences in Fabric. The compute is completely separate from the storage. And we have multiple computes that are available. The different Fabric workloads leverage multiple analytical engines to serve their experiences. So you can pick the right engine for the right job in these cases. So we have a Spark engine, which Ted's going to go into more detail on, powers our data engineering experiences, our data science experiences, powers a lot of data factory as well, too. We have our T-SQL engine, our data warehouse endpoint. It powers our data warehousing. The KQL engine, it powers all real-time analytics. And I'm so happy to actually be able to say analysis services again in an actual presentation. But that is the engine that powers all BI and Power BI. So multiple engines, all with different pros, different cons, but optimized for different usage patterns, different scenarios. All of them are available. And what we'll do here is by default, each engine is going to write its data to OneLake. And it's going to be in Delta Parquet format. If it's tabular data, it's going to be in Delta Lake Parquet format by default. Now, what this means, though, we haven't created any proprietary file formats here. Everything is going to be, if I do an insert into a SQL table, it's in Delta Lake format in OneLake. If I load data with Data Factory, it's in Delta Lake format in OneLake. We haven't created any proprietary formats. So anything can read this data as well, too. And we specifically picked Delta Parquet format, so we have some standard that every single engine could align around. So what's important here is that not only is it written into OneLake when it's tabular in Delta Parquet format, but any engine can now read this. So the Spark engine already could read Delta Parquet format. We've reworked the SQL engine to natively work directly off the data in OneLake in Delta Parquet format. Analysis Services now has a new Direct Lake mode, which pages data directly from the Parquet files in OneLake directly into memory. No more processing or making that extra copy of the data just to get into Analysis Services and then keeping that up to date. Read it directly from OneLake into memory and just start using it. So you can now start to use the right engine for the right job. This is a concept we call one copy. One copy really aims to give you the most value possible out of a single copy of data without any data movement or any data duplication. Analysis Services is able to pull this into memory without that extra copy, without that extra import. Not only does the data warehouse engine not do an extra copy or import, it doesn't have a place to import it to. OneLake is its native store now. So thanks to one copy, the decision of which engine to use to build your analytics solution really comes down to a matter of preference. It's really separate from now how you're going to consume the data. So you can use the right tool for the right job. If you have a data engineering team that's been doing stored procs and T-SQL for the last decade or more, they can continue to do that. If your data engineering team prefers to use Spark, and they want to build notebooks, and they want to land data in a Lakehouse, they can do that. Everyone builds the same lake. All this data is going to end up in OneLake in Delta Parquet format and can be shared across all these engines. This is even true if you're not using a Fabric engine. With open access APIs, we've also made that storage layer completely open. So we've taken the same ADLS Gen 2, Blob, and DFS APIs, and all the SDKs they support, and we've made that available on OneLake. So any application that knows how to talk to ADLS Gen 2 is already compatible with OneLake. This includes Azure Databricks, Azure HD Insights. And if you've worked with ADLS Gen 2 before, this will be very familiar. Instead of seeing all the hundreds of storage accounts we have underneath the covers, you only have one storage account to remember. It's OneLake. It'll appear, your entire tenant will appear as one virtual storage account, and you essentially address it as such. Now, every workspace you have essentially goes in as the container. And then the different data items, the data item will be like a lakehouse, a warehouse. The different data items will be organized into folders underneath that, and you just address them as files at that point. So this should be very familiar to you if you worked with ADLS Gen 2. And this lets you now read and write data to and from OneLake with any application that already knew how to work with ADLS Gen 2. Not only that, if you knew how to work with SQL, the SQL endpoint will read and write to and from OneLake. So all the things that you have and been working on so far should be compatible and be able to work with the data in OneLake, no matter how it got there in the first place.
Does this mean that everything else, taking obviously example of Azure SQL database and everything else is moving in this direction? Or is that
One can hope. But, so right now, this is just the engines I'm talking about here. Our ambition for OneLake is that it is truly your OneDrive for data, and every bit of enterprise data automatically just lands in there. So, it's a vision. We're working on getting there, and this is a huge leap forward right now. I mean, just seeing our data warehouse engine natively take a dependency on OneLake, seeing analysis services, which is something I never thought would happen. Skip the processing step now by working directly off OneLake is a huge step forward, and we'll continue to make these steps forward with as much as we can with the rest of the data products. Actually, yeah.
Yeah, you mentioned about the direct link, right? So like when users analysis service, you don't need to process, and it will be in the memory. That is called direct link.
Direct link, yeah. So you have direct query, which was real time and maybe a little slow. You have import, which is very fast querying, but a little latent because you got to keep it up to date. Now you have direct lake, which is kind of just right. It gives you the best of both.
Is the direct lake and OneLake is different, or is it the same thing?
It's a feature of using the data in OneLake, essentially. Yeah. So I'll do one more, and I'm going to hand it to Ted to actually show you a little bit more of how the data engineering workload works on top of OneLake.
The data is stored as Delta Parquet format.
For tabular data, yes.
So, only for tabular.
You can store data whatever you want, any file format. By default, our engines will store it in Delta Parquet format, and every engine they want to say they're part of Fabric is going to have to say they know how to read it in that format too.
So if we upload a JSON file, it will automatically convert the JSON?
No. You upload a JSON file, you get a JSON file. If you upload it to an engine that knows how, so if you upload it to Data Factory and then you tell it to output it as a table in a lakehouse or a warehouse, then you'll get a Delta Lake file.
Yeah, it depends how you upload the file. You can upload binary, then it will be just binary copy, but you can do the transformation to different formats.
Yeah, well, I think it's a good time to transition to you and let you show some of this.
Yeah, so basically what Josh was talking is about OneLake concept, which exists in Fabric, and everything is built on top of OneLake in Fabric.
Microphone on?
Can you hear me better now?
Is your
Is the microphone on?
mic?
Hello?
His mic's not on. Okay.
Hello? I might be able to shout.
Okay, you take this.
Better? No?
I'll give this one.
Can you hear me now? Yeah, you can. That's good. Okay, so yeah, OneLake, basically that's where all your data sits. Now, how to get that data, how to put the data in, that's a different question. So in Fabric, we have a data engineering experience. And what data engineering experience consists of, you have a lakehouse, which is abstraction layer on top of the OneLake, and it stores data such as the tabular data in Delta format, CSV format, actually any other format which is supported by whatever engine you are using to actually query it, whatever runtime you query. One difference from the Lakehouse, because Lakehouse as a concept you most probably heard before, and many other products provide that too. What we have here too is, in addition to basically just storage, we also provide different ways of querying data. So you can query data with Spark, but you also can query data with T-SQL without making any copies, without need to have another data warehouse provisioned or anything. Analysis services, we also provide semantic model. Used to be datasets, now they are called semantic model, which automatically allow you to build reports on top of the Lakehouse without you need anything like to make another copy or copy data anywhere. So the data still sits in OneLake. On top you have abstraction of the Lakehouse, and that basically serves most of your needs. Data engineering also consists of Spark runtime. So if you need to run any Spark jobs or any other engines, basically we support that, and we have multiple versions of that. Developer experience, so notebooks, Spark job definitions, all of that is in Fabric, it's all in data engineering experience. And all of this, of course, is integrated into the platform. So things like access control, lineage, scheduling, all automation, all of that is there. And another great thing is that the other experiences, like data integration experience, is also tightly coupled. So we'll go through some demos showing, for example, how you get data into the Lakehouse, and that uses actually tools which are provided by data integration tools. So quickly, what's the Lakehouse? It's a storage where you put your data in order to analyze afterwards for data science project or for business intelligence reporting. Scalable, flexible. You don't need to worry about provisioning any storage. All of that scales automatically as a true SaaS solution. As I mentioned, you have built-in T-SQL endpoint, which allows you to query data using T-SQL in addition to Spark SQL or using code with Spark. And it has a direct lake mode for the semantic model. So you take the files, these files automatically loaded into memory and available for Power BI without any sorting, without any filtering, without any additional engine in between. The way files are stored, the way files are formatted in the Lakehouse, immediately can be loaded to analysis services. Okay, so let's go quickly through the live demo, pre-recorded demo, but actually showing the tool as is, how to provision a Lakehouse. And you'll see how easy it is. So you are in data engineering experience in Microsoft Fabric. That's what you see once you enter Microsoft Fabric. So first thing what you do, let's see if demo is running. Yeah. You basically choose a Synapse Data Engineering experience. From here, you either create a new workspace or choose one of your existing workspaces where you will be holding all of the items. So in that case, I choose my existing workspace. And then you click on New, choose the Lakehouse, enter the Lakehouse name, and it gets provisioned. You don't need to do anything else. You don't need to specify size. You don't need to specify where it's being located. It's in that workspace which you chose, and it's there. As you see, in the Lakehouse, we have two folders immediately there, tables and files. Tables is a basically folder which will store all the Delta tables which will be available for T-SQL queries or other engines. So it's kind of your transactional database. Files is your more like data lake where you can put images, videos, and other things into it. In addition, when you provision Lakehouse, as I mentioned, you're getting also SQL Analytics endpoint and semantic model. So as mentioned, if we go now back to our Lakehouse, you can basically switch the mode to SQL Analytic endpoint, and now you see a data warehouse interface which works in read-only mode and queries same data which has a Lakehouse, which you could query with Spark without a copy. Nothing has been copied. The data sits in same OneLake. On top you have Lakehouse, and now you can query with SQL endpoint. Also, here you see there is a semantic model, used to be called datasets, which is also acts in the same way. It basically points to the same data which is stored in OneLake and loads that data immediately at very fast speeds, and you can get that data available for Power BI reporters reporting through the semantic model. All you can do here is just apply some modeling, which then you would be using in Power BI report. Okay.
Oops. Okay. So, sorry, I thought I was missing a slide for a second. You saw there where Ted was making a lakehouse. A lakehouse, from a OneLake perspective, should be a folder within a workspace. Workspace is going to be nothing more than another folder or container within the lake itself. So everything here is stored within OneLake. And really, all roads start to lead to OneLake in this. All roads start to lead to OneLake here. So everything he did to bring data in lands in OneLake. Use Data Factory to bring data in. It's going to land in OneLake. You insert a row into a data warehouse. It's going to land in OneLake. In addition to the native engines of OneLake, you have the open access APIs, that entire ADLS ecosystem that's available. So Azure Databricks, so Azure HDI, not newly announced, the newly announced Azure AI Studio, all available, and anything else available with ADLS Gen 2 is compatible with OneLake. But these are all bringing in physically landing data in OneLake. What if your data, OneLake is really an open storage system here. We used open file formats, we used open APIs. We didn't invent anything new in terms of how you read and write the data. And we did that on purpose, so we'd have this compatibility. But we're not the only open storage system out there. So what if your data is already available in one of those open storage systems? Most of your data is probably not in OneLake today. We have this concept of what we call MultiCloud Shortcuts that let you virtualize data in across multiple clouds into OneLake without any data movement or any data duplication. Shortcuts provide this connective links between different business domains, different workspaces, and different data items. So let's say, for example, you have a data warehouse, and you have data in there, and you want to use that in a lakehouse. In the past, you'd have to extract it, put it in the lakehouse so that Spark could get to it and other engines could get to it natively. Here, just like in Windows, you can create a shortcut. Shortcut's nothing more than metadata. It's a symbolic link. It's a pointer. So if you're in Windows and you create a shortcut to another file location, that file location will appear as if it's physically in that shortcutted location. But it's not physically there. We didn't copy it. It's just a reference. And because of that reference, you didn't change the ownership of the data. You're not now responsible for keeping any copies up to date. When data changes in the original location, they'll automatically update in the shortcut location, because there is one copy of data. Now, this works within OneLake, so I can shortcut from one location to another. I can shortcut across workspaces in OneLake. But we extended this to data outside of OneLake. So if your data is sitting in ADLS Gen 2, you can shortcut that directly into OneLake. If it's sitting in Amazon S3, you can also shortcut that into OneLake. It'll appear in OneLake as if you had copied it in, but no data movement has occurred. So everything maps to the same hierarchical namespace, the same API. So now I can access data through ADLS APIs, even if it's coming from Amazon S3. The downstream applications, the downstream engines don't even know that this data is coming from a shortcut. We've integrated this so low in the stack that all the functionality above it just works. Question?
If it is a transactional database sitting outside,
Yep.
will it impact your performance?
So if it's a transactional database sitting outside, I'm not aware of any transactional database right now that actually supports an open storage layer. So this will be things like AWS Gen 2, Amazon S3, coming soon Google Cloud, not quite available yet. Dataverse, which is the backing store for Power Apps and Dynamics 365. They did a lot of work. And they're another SaaS service, but they did a lot of work to make sure they could expose their data through an open storage layer. So we can actually shortcut to them now, and this is available, without any data movement. But anything that's still using proprietary storage, proprietary formats, their data is walled off, that data is not something you can shortcut. We do have a solution for that. It was actually announced in parallel, so I didn't have it in this deck. But after this session, check out data mirroring, which is a new feature coming soon that's meant to address exactly that scenario. Check out data mirroring right after this. That's exactly meant to address that scenario. Essentially, if they don't have the open storage format, mirroring is the next best option. So your options to bring data into OneLake today would be to copy it in, use Data Factory, build a pipeline. If it's in an open storage layer, an open format, which the trend is going that way, you can just shortcut it in. No data duplication, no data movement. Somewhere in between is what we're doing with mirroring, which will let you actually do a much more shortcut-like experience, but it's still doing replication, but we're managing that replication for you. And there's a much more full announcement in the Runes Ignite session, which should be online. And then anyone sticking around for Ignite, we'll have a OneLake session tomorrow as well, where we'll go into much more detail on this, now that it has been announced as of a few minutes ago.
So how is the performance when you're pulling data, say for Power BI model, from one of the shortcuts? Say that you want to reverse data into your Power BI model. I assume it's just making the REST API calls, so it really depends on the speed of the API.
Yeah, so what's the performance really of a shortcut compared to just data natively in OneLake? Like I mentioned, it's very low in the stack. So these systems are set up to retrieve the data from storage to begin with and already kind of set up for this to be distributed. So the fact that it's actually not coming from the same location is actually not a big difference there, particularly if they're in the same data center. You're really not going to see any difference. Beyond that, when you start going cross clouds, cross data centers, it's really about, think of the normal extra latency you'd get when you just go cross region in general. So not crazy big, I mean, but it'll be a noticeable difference there. But it only applies for most of the, it really depends on the engine to some degree, but really for something like a Power BI, it only applies to really the cold scenario, the cold cache scenario, because it's going to page it into memory. So once it's into memory, everything after that is just going to fly at the same speed, whether shortcut, not shortcut, import. As long as it's not direct query mode, it'll fly at the same speed. How are we doing on time?
I think we have
20?
time. Yeah.
Okay. Let me take 2 more.
So the question is that if you create shortcuts, and so you have to add the shortcuts to each workspace, or it's added at the fabric level?
So you create a shortcut within a data item. So in a Lakehouse, you can create a shortcut. It'll be part of that Lakehouse. Now, you can access it from other workspaces. You can access it from outside of Fabric. But it's modeled and exists somewhere. And that's how you address it. So you address it in that one Lakehouse. So think again, a file system. You'd create a shortcut in one location in the file system. Here, you'll create it in the Lakehouse in one location. Now, you can reference that shortcut from another shortcut. You can chain them all together. There's lots of possibilities there. One more?
So do you have a recommendation for when you're ingesting data from, say, like a replication source or BitLead or something like that? Do you land it in the Lakehouse or the data warehouse? Because
Solid question. I'm sure Ted has a recommendation.
It depends on the usage pattern. So if we'll go, for example, with the Medallion Architecture, so it's basically at the bronze level, if you don't serve the data, but you just do mostly transformations with it, maybe you don't need a data warehouse exposing T-SQL functionality and all of that thing, then you want to do everything, for example, at the Lakehouse level. The higher you go, for example, to gold layer, that's already like Power BI level. That's where you want all the analysis services to work and other things, and that's where data warehouse performs better.
right now, in our Fabric, we ingest into the Lakehouse, but we still have a semi-bronze
Yeah.
architecture to where we kind of clean it up.
Very good solution, yeah.
And I'll tell you what I did. My last 20 years of experience is really with SQL. So all my engineering experience is really just with stored procs and building databases. But there's something so cool about the Lakehouse and being able to just bring in any type of data, just land it in there, and then deal with it and work with it later, that I wanted to have that flexibility, but I don't know Python yet. So what I did was I created a Lakehouse. I landed all my data in there. It's just so clean, so easy. I put a data warehouse in the same workspace. I could do cross-database queries and built some stored procs. I actually did the transformations, built out the fact tables, built out the dimension tables, and I shortcutted them right back into the Lakehouse. I had everything now in one Lakehouse, in one workspace that I could then build my reports and everything on top of. So I got the best of both there. It really does come down to a matter of preference and how you want to work.
One more little thing. Are there any sessions here about time travel and what happens when you clean up?
I don't think we have these sessions, but to be honest, at the moment, from the capabilities on the time travel, it's whatever the Delta Lake provides you. So each time you write something in the Delta, the record is stored, watched to the past. And currently, the capability for time travel is mostly driven with code. We are planning to introduce, of course, the UI element too.
We just have questions about when you clean up, what happens to that?
All your, because it's a Delta Lake, everything, you set up basically your vacuum specification, how often you want to clean up. And by default, it's 30 days. So everything what's been for 30 days still stays there.
Tell me if you have time, take more questions, or do you want to?
I think let's move on maybe because I'm worried we have half an hour left.
Nope. Yeah, some of the slides.
Yeah.
So I mentioned also shortcuts to Dataverse. How many here are you actually using Dataverse? Okay. So this came out in public preview a few months ago with the GA Fabric today. This is also now generally available. So you can now do shortcuts to Dataverse as a supported GA feature. One last thing I talked about earlier, Databricks can land data natively in OneLake and read data from OneLake. This has been available. But also, if you're already landing your data in ADLS Gen 2 or Amazon S3, you can go ahead and shortcut this into OneLake. You don't even have to move it. Now, this works a lot better with non-Unity managed data. It's a little bit harder to find and see with Unity because there's not a name on the table, and you have to find the path. But for non-managed Unity tables, this works great right now. Shortcut in, same with the reading and writing directly to OneLake. We are working with the Unity team right now on having an enhanced shortcut experience that can actually work directly with Unity Catalog and bring you those managed tables as well too. A lot of Databricks users here? Yeah. See, Ted, you got some room.
Yeah.
So with that, let me actually hand it back to Ted, and he's going to really finish this off with a lot of demos right now and just show these things in action.
Yeah, so the things we talked basically about data ingestion into Lakehouse. As I mentioned, Lakehouse is abstraction level or top of the OneLake, and there are multiple ways how you can get data into the Lakehouse. We basically implemented the basic one where you just go to your local machine and upload the file. You can use data flows to connect to over 120 connectors, different types of databases. You can use Spark code and basically write the code yourself and get it in. Shortcuts, another great example of, I don't want to make a copies, or I have already my data lake somewhere, and I just want to put the data into Fabric so that basically I could try to use the workloads like Spark, like Data Warehouse, with my data stored somewhere else. Maybe that's good for the bronze layer where I don't want to make any changes, but then I make changes and I can store the silver and gold layer already in OneLake. So let's look at the demo and the key ways of getting data in. So I'm in my Lakehouse, which I just created. Let's see if the demo, yeah, now it's running. And let's say I have a data which is stored in my ADLS Gen 2 account, and I want to bring it, but I don't want to make a copy. I want to just to reference it and be available for querying in my Lakehouse. So what I do for that, I basically can go and create a shortcut. So there are multiple ways of creating shortcuts. One of the ways is directly when you have an empty Lakehouse, basically clicking on a new shortcut. You can go for the top menu in the Get Data, or you can choose where you go on the table and views. So once you click a new shortcut, you get an options to select. Do you want the shortcut internal or external? Internal is just to shortcut to OneLake, external to ADLS Gen 2 as free account or whatever. So if we go to ADLS Gen 2, we need to specify the URL path. We need to specify how we want to authenticate. There are multiple ways of authentication. You can use AAD account, or you can use basically account key, which Azure can provide you. So once everything is set up, I click Next, and then I specify the shortcut name, which basically will be either my folder name or table, depending on where I'm creating shortcut. If I'm creating in table space, as in this example, what happens now in the system, it automatically scans what are the files in this folder, and if these files are Delta Lake files, it registers it as a table. So now I see all the data here when actually it sits in my ADLS Gen 2 account. For Lakehouse doesn't understand if it sits in OneLake or it sits in external drive. I see a different icon which implements that it's a shortcut, but basically it's data there. Another way, if I want to make a copy of the data, I can create a pipeline with ADF. So I create a new pipeline, also by just clicking Get Data, new pipeline. And there I'm getting a dialog to create a copy activity. Very similar to shortcut, but in this time, yes, I'm also going to specify what is my source. So I'll go to ADLS Gen 2, specify my connection, so enter, I will be entering my URL, account key. And the difference here, a little bit of experience, which actually we most likely will be improving on shortcuts too. Now I'm able here to browse for what I am actually trying to ingest. So I can select either multiple files or a single file. And in addition, I get an option. So I'm selecting like a CSV files. You see, I'm not looking anymore into Delta. And now I have two options. It's either make it as a binary copy, so that it will copy just a CSV file, or I'm able actually to transform that and land it as a Delta table into my Lakehouse. So I won't need anymore to do transformation. I can let pipeline perform that. I chose to do it transformation, create it as a table. So I select which Lakehouse it will land to. Basically, it's pre-populated because I was going from that existing Lakehouse. It provides me a suggested table name. I can change it if I want to. And then once that setup is done, I just need to save and run that pipeline. I can run multiple times afterwards. It basically will be refreshing the data. But once the pipeline run is complete, usually it takes much longer than your shortcut because shortcut is instant. Pipeline still needs to carry all that data, but the speed is phenomenal. So here is the result. I'm getting also table published. So, but this time it's a copy. Now this data is stored in OneLake. And you can see maybe that the icons is somewhat different. One of them has like a shortcut icon. Another way is, what about streaming data? You can use it with Spark structured streaming, but also you can create a new event stream. So there's another integration, and I'll show you examples. So I'm creating new event stream, and event stream, I can specify where I will be taking my streaming data. And there are multiple ways to do that. You can take it from Azure Event Hub, from Azure IoT Hub, or your custom app, which basically pushes the data in JSON format. That can be pulled by event stream. For this example, we'll just take sample data, like stock market data. And once it's set up, once your source is set up, it starts streaming into event streams. All we need to do now is go and specify where we want that streaming data to land. So I go to the output, Lakehouse. It has already pre-populated Lakehouse because I was creating that experience from existing Lakehouse. All I need to do now is to specify table where I want that streaming data to land. So I add new table, click add, and once the new table is created, I can go back now to my Lakehouse. And you can see I have another table which basically has streaming data which constantly gets added there. So in some ways, very quick way to get the data in, multiple ways to do it, multiple types of data, and yeah, many options available. Not all of them actually were shown here. Say question.
Yes. As the next leg of this process, we make available to the semantic model, Power BI. How does that refresh work, if at all? How does it work?
So yeah, I'll go a little bit ahead and tell you. So all of these tables, which you see here, automatically referenced in semantic model because everything is stored in OneLake. So semantic model by itself doesn't have its own storage. There is no need to make a copy or anything. Everything sits in that same place. So all semantic model does, it just points that, OK, take files from here. All Lakehouse does just points, this is where the files are. So how the magic happens and how Power BI sees it is these files are taken and loaded to the memory into analysis services, where we're getting the speed because these files already, so OK, they are compressed in Parquet format, so there's a compression already applied. But we also apply sorting. It's called verti-Parquet sorting. You can read it in our public documents. It's sorted in such a way that analysis service can actually query data very fast, large amounts of data. So there is no need for analysis services to pick the file, load it into temporary memory, resort it, and then be ready to serve it for the Power BI. It's immediately available. So the time it takes to pick up the file and load to memory, that's all it takes.
So in the interface to a report, the dashboard, the refresh, of course, virtually automatic.
Yes, this is automatically.
Once the data lands, you start to see it.
Yes. Behind the scenes, there is some caching, there is some magic happening too, but in principle, like there is no direct query, there is no need to go back into the file, ask for anything. Yeah.
So when you create the pipeline, right, you're physically you're moving that data,
Yes.
right, versus the shortcut. What about the refreshing of that data if you create a pipeline? You have to like do some sort of schedule to make
Yes.
sure it refresh?
So basically, yes. With pipeline, there are multiple modes how you want to land data. You can overwrite data. You can append data. I don't think we have an update yet, but that's where you choose the modes how you want. So once you rerun the pipeline, it basically goes to the same source, picks up the file, and starts to land. And then it can land as append. So if your source, for example, has just a change of data, it will apply just the changes in. But if it has like a full new data, yes, it will just overwrite existing table in a OneLake. And the magic, again, will be solved because it's a Delta format. With time travel, you will be able to go to previous versions too. Yes, and the scheduling, yes, and the scheduling is available both in the platform itself and also pipeline can be scheduled. So you can put in pipeline much more complicated logic, which will trigger that copy activity once you want. So not necessarily it's time-based, but it can be some event-based or anything else.
And then when you do a shortcut, so you don't have to worry about scheduling.
Exactly.
If you're going to make an explicit copy or make a transformation, then you're still managing that copy of that transformation. But once you have the data in a form you want to use it, you don't have to make any copies.
Yeah.
From that point forward. It'll work with every engine.
Yeah.
And if it's already in that shape, just shortcut right to
Yeah.
it. And shortcuts, by the way, work on any type of file, not just Delta Parquet.
Yeah, and as just mentioned, is another thing is matters, like where is the data located which you're taking from source. It's in another different region. Maybe it's not the best way to query it constantly because you are getting network latency. So you might want to create a copy, but in many cases, actually, you don't. So that's where shortcuts are really powerful.
So between the shortcut and the physical copy of the table, so what is the performance seems like? So like shortcut, you are just referencing and you are coding the data.
Yeah, it's going to vary. So like I mentioned earlier, these are already designed to be distributed systems or designed to get data from different places already. So it really comes down to where your data is physically located. If they're all in the same data center, you're not going to notice any difference, whether it's OneLake or ADLS. You start going cross regions, start going cross to S3, if they're still somewhat located close to each other, you'll, the same type of performance you would get when you go cross region normally. A little bit of extra latency there. You'll get egress. It's one of the problems here. But how that actually impacts your overall performance is going to vary by engine. Spark, you'll probably notice it. Power BI, probably not so much, because it's going to page everything in the memory, and once it's in memory, it's in memory. It doesn't matter where it is at that point. It's going to be in memory. Same with the T-SQL endpoint. There's going to be a lot of caching there, and once the cache is there, it's going to be no difference.
But between these two, the physical table might have a little bit good performance? Or?
Well, so think of where your center of gravity is for your data. If you're doing stuff in S3, in Amazon and in Azure, it's going to cost you to move the data anyway and keep that up to date. It'll probably be more beneficial for you just to reference it as a shortcut. And we have some things coming we call smart caching, which is getting close to our public preview. It's not quite there yet, which is designed to reduce those egress charges. And it will help with the latency too. But essentially cache the data locally as you use it, so you don't have to keep going back every single time. And those caches can be shared across all engines, all workloads, all users, all personas, to really mitigate mostly the cost problem there of the egress.
So to give a specific example, as I mentioned, there are two types of shortcuts, internal and external. When you make internal shortcut, you're basically pointing to the same storage. So the overhead is negligent. There's none overhead. If you go external, then all of the network things add up and so on, and it would be the same as you could.
External outside the region.
Yes.
So every workspace will be in a certain region. If you stay within that region, it's basically the same for internal or external.
Okay, last question, and I'll go for a couple more slides.
Let's say if you're working with S3 bucket, how quickly can it recognize new files or a file disappearing when you're visualizing it and seeing the files in your storage?
It's within a few seconds right now, it'll recognize it. We're still tweaking that logic a little bit, but right now, yeah, you should see it almost instantaneously.
Okay. So let's go for the last kind of demo. And OK, we landed the data, but now we want to maybe transform it and serve it. We kind of discussed a little bit already about these topics, but let's just go through the ways of transforming data and then serving into the customer. So again, many ways to do that. You can use data flows. You can use complex transformation with code, implement Medallion Architecture, and provide access actually in also multiple ways when you serve that data. Let's look at a couple of things in the demo. So first thing, OK, I have like my table orders, and now I want to transform it, maybe just remove a couple of columns and serve it to my Power BI users so that they would be able to report that. So I don't want to serve the same Lakehouse because that already contains the data. So what I'll do, I'll go instead and create a new Lakehouse, which will be my serving Lakehouse. How you choose to implement your Medallion architecture, is it in a different workspace or so on, it's up to you. Within a tenant, everything is being communicated. You can do cross-workspace shortcuts, cross-workspace data movements. That's not a problem. So once I created my new Lakehouse, I go to new data flow. And for those who work with Power BI, the interface is very familiar. I choose the data source, which will be my original Lakehouse, which contains the table orders. So I choose from the list my Lakehouse. Choose which data I want to transform. Select orders table. And then I have multiple ways of transforming it. Basic one, removing columns, but there are much more complicated ways which actually also through UI interface data flows allow you to do that. But for this, we'll just take a couple of columns, remove them, and now we see the transformed data here. As a next step, we need to specify where we will be landing this transform table. So we already selected the Lakehouse. All we'll need to do is specify the table where it goes. So as a destination, it says Lakehouse as a connection. I search for where my Lakehouse is. So look for the workspace. Here I select my serving Lakehouse and just use orders as a table. Click Next. Once the data flow is saved, I need to publish it and refresh. Basically, that's the Power BI world. That's how data flows work. So it's a little bit different than how pipelines work, but principle is some way similar. So once data flow is published and refreshed, I now go to my serving Lakehouse, and I can see that there is a new table here created, and this table doesn't contain those 2 columns which I removed. So that's one way of transforming. Pretty basic. You can apply complex transformation, but not as complex as, for example, I would like to apply with the code. So if you want to do it with the code, you can use notebooks. So I go to my source Lakehouse and just go and create new notebook, which will be linked to that Lakehouse. So in the notebook interface, I can already see that, OK, here are my Lakehouse tables. I just paste the code. The code is very simple. Basically, what I'm doing, I'm loading the table. I'm filtering certain column with certain value, like specifically I'm looking for a certain company's ticker. And then I will be writing it down to a different Lakehouse, to my serving Lakehouse in a different, as you see here, specified in different Lakehouse. And as soon as this code is run, I will go to my serving Lakehouse and see if everything is done. Cool thing with Spark here, you don't need to provision any compute or anything. All is pre-provisioned for you. You can run Spark immediately without any additional provisioning of your capacities or anything else. So now I go to my serving Lakehouse, and I see another table created with the code, and that basically has sorting data. Now, if I want to serve it, that means I want to share it with some of recipients. I have 2 ways. One way, I could add them as a contributor to Workspace, but then they will see everything. Or I can share this individual Lakehouse, the serving Lakehouse, with any group or any member, give them specific access, and these members will be able to see just that particular Lakehouse which is served to them and build Power BI reports on top of it, do data science projects, whatever they want. So I don't need to expose them all of my notebooks, all of the data flows, all of the pipelines. I can just expose a specific item, which is that serving Lakehouse.
And remember, Ted here is also showing you how to load data through the Lakehouse. Showed it using Spark, using various means here.
Yeah.
I know a lot of you are SQL people, and you're coming from the data warehouse perspective. Same is true. Remember, the same is true there. If I go with the data warehouse, I load my data using T-SQL, full power T-SQL there, full power store procedures, still ends up in OneLake, still ends up in Delta Parquet files. Everything from that point forward is the same as everything Ted's talking about here.
Question?
The share there, so you're sharing with somebody outside your organization, essentially. Is that a true statement?
No, you still share within your AAD group. Like you're still sharing within your directory, within your tenant.
Do they still get a SQL? They get a SQL endpoint that they can then use, like an SSMS?
Yes. So when I share
Anything else, just what you shared with them?
when I share Lakehouse, I share so-called trifecta. I share like semantic model, the SQL endpoint, and the Lakehouse. But I can specify what access I give to them.
Okay.
So I can specify that I give you only Spark access, but not T-SQL, or only T-SQL access, but not that.
It'll just be that resource, not.
Exactly.
On the notebook, can I point to the notebook already on Workspace 1? Data is on Workspace 2 as well, and it joins here I imagine here the shortcut. Now, how does the output, can I lay anywhere, or only within the workspace where I have that
anywhere where you have access. So when you will be trying to write an output, say like a table, we'll still check if you have a permission to store in that workspace in that particular item. But yeah, you can reference any point, like within that tenant, again, you cannot go outside of the tenant.
This is literally the OneLake, so you can write it to any place in that lake.
Unless you're using Notebook to write in some ADLS storage account somewhere else, that's also possible. So you don't need to specifically use, Fabric resources. Like with Notebook, you have all the freedom.
But the operation in terms of control, as one outlines, you have the tenant, inside the tenant, you're going to have the different workspaces.
Exactly.
As long as you have that
Yep.
link to the different workspaces.
As long as you have access. Yeah, links make it easier. I mean, it's just it's an easier path to follow, but you really just need access.
We were told yesterday to not use the default semantic model.
Who told you that?
In what cases? Let's see.
What's it? Adam? All right. Adam has his reasons, I guess.
It wasn't saying that default data set. That was created by the process.
Yeah, I'll have to check with him and see what his guidance was there. I mean, there were some drawbacks in the earlier preview with the default data set, specifically on data warehouse where it wasn't using direct lake mode. Those have since been fixed. So data warehouse will now use direct lake mode.
So the default data set is built for ease of use. So to remove additional step, but there is no problem for you to go into the Lakehouse and create custom data set with filtered tables if you want. So sometimes you might have in the Lakehouse so many tables, which that's what normal Lakehouse contain, but your default data set might become too big for your consumption. So that use cases, maybe it's better to create custom data set. But it doesn't mean for the 95% of cases that you shouldn't be using it. It's still fine to use it.
There's always going to be multiple right answers to some of these questions, too.
Yeah.
With the desktop client, which synchronizes down like OneDrive, that scares me completely. Because, you're giving people direct access through their laptop or whatever to the OneLake. What kind of controls do you have to stop people deleting a random Parquet file from the table? Or can you different areas?
Well, so for certain data items like a warehouse, it's going to be read-only, so you can't delete anything. For Lakehouse and some of the other items, it's whatever access you have. So don't give them read access. Don't give them write access if you don't want them to delete in those cases. If you give them write access, they can delete there, but they can also delete in a lot of places too. If they have the ability to delete, they can do it from a lot of experiences.
But you can specify that at a folder level.
You can specify that right now at a data item level. We're working on something we call OneSecurity, which gives you much finer-grained access that will let you go down to a table level, sorry, a folder level, and also a table level. Actually, also a cell level when it's all done.
So general practice, you really need to be careful within your organization whom you assign admin members and contributor roles. Because we try to keep the platform as open as possible, and that means that you can shoot in yourself in the leg very, very easily.
But especially if you're doing a dev environment, a lot of people might, at least the developers might have right access to that. But production, they hopefully don't. And hopefully no one does in that point. So you follow the same best practices, you should be safe. We didn't try to invent anything new here.
In the streaming example, what kind of scale did that handle? Let's say you were adjusting 10,000 events a second. What would that look like? And if you tried to hook Power BI up to that, what would that look like?
So Power BI will see only files coming and lots of files being created. Now scale, it's very much similar to what Event Hubs. It depends basically when you set up Event Hub, how many nodes do you provision there? So that's your scale. Within the fabric, the event stream itself scales automatically. It kind of understands, okay, this is the Event Hub which I connected to. This is how big it is. It scales to automatically. And then at the storage level, because it's distributed storage, it can write very quickly into it. So everything scales. That's the point here. But your Event Hub, your initial source, you set it up how you want, how much of the data actually you get it. So if you have like, I don't know, thousands of IoT devices, but you have only one node on your event hub, that will be your bottleneck. But if you scale it, everything else scales after it, and it uses your capacities, so you will pay more.
In general, especially with big data, try to get into small data as fast as possible. Aggregate it down, because it'll work, but you're going to pay that cost every time of trying to read data and then aggregate it down at query time. If you do it sooner, then everyone can just share the benefit of that aggregate.
So you're talking about the importing from outside, from manufacturers, insert in, you talk about the fact that updates are coming later. As part of that update, will it support things like type 1, type 2 situations to be able to take full data sets and do that behind the scenes, or am I still going to have to manage that myself?
I think you'll still have managed it in code. At the moment, we don't have support of like updating changes. It's to be honest, I'm not representing like a pipeline team, like a data factory. They usually own that piece. They do have that in the roadmap. But as of today, it's like these two modes, which is mostly like overwrite and append. And
in the data warehouse, you can insert an update too.
yeah.
So you can, you're going to still be doing the pattern though to do kind of the slowly changing dimension, but you can update rows and insert new rows there.
But it doesn't have any components to make that easier. I'm still going to have to code for it.
Yeah, you're going to code it in C-SQL.
Okay, thank you.
So when we are running the notebook, so you said that like Fabric automatically provision the Spark cluster. So like if I want to run the bigger data, so like I need to assign medium or high. So like how would you like to do it in Fabric?
So the way it works, basically, it scales also automatically. It looks at, it provisions certain capacity. It starts to running. If the processor load is high, it adds another node up to your capacity limit. So it doesn't go above. You suddenly don't, like if you are paying only for like 4 nodes, you will not get 20 nodes available for you to run. And then you have multiple jobs running, so it's also important to manage your capacity accordingly, so to make sure that everything gets some compute capacity.
Yeah, but in few tables I need to run it in medium, few tables I need to run it as low. So in Synapse, like we can create a multiple pools where the low and medium and high. So like where certain tables can go to this medium pool, certain Fabric we don't have anything like that. So
in Fabric, you can specify certain capacities which.
Well, yesterday they showed us it's not possible yet.
Same question yesterday.
With Fabric
Yeah, with capacity management, to be honest, I'm not the best specialist, but there are some improvements coming also around elasticity and so on. But the way you do it today is you assign capacity to certain workspace. So that's how you can manage that. You have different capacities for different workspaces, and that's where you can go like, okay, this is my high throughput work, this is a low throughput, this is my dev environment, and so on.
Now you can do shortcuts into another workspace that might be using another capacity, and then you can use that capacity then to actually access that data. So there is some separation there. I think we're actually at time. Maybe we can take more in the hallway if you want to. Thank you.